The first example for design the storm sewer. Before we go through this example, we move back to this catalog. This catalog is the concrete sewer available in Thailand. Okay, from the Universal Concrete Products, or the brand name is Unicorn. Okay, so this is the catalogs for the diameter of the concrete pipe. In this case, we call the type of the concrete pipe is Ba Lin Lang, or tongue and globe pipe. Okay, it's typical design in Thailand. Okay, and the diameter is vary from 30 centimeter to 150 centimeter. Okay, and they also have different type of the concrete, RC1, RC2, RC3, and RC4. It depends on the strength of the concrete. Okay, and the reinforcement. Okay, you can choose from this catalog is from diameter and is the thickness of the pipe. Okay, we move to this example. This is hypothetical drainage basin comprised of 7 subcatchment shown below figure. Determine the required capacity of the storm sewer EB. So this is a pipe EB. Draining sub-area 3 for the 5-year return period storm. This subcatchment has the 4 acre and runoff efficiency is 0.6. Inlet time is 10 minutes. Okay, so inlet time, this is about 10 minutes. Okay, flow to the outlet. The design precipitation intensity for this location given by this equation is a function of the T and TD. So I is intensity in term unit is inch per hour, and T is a return period. TD is the duration in minutes. Ground elevation of point E and B are this feet above mean sea level. And the length of pipe EB is 450 foot, assuming n 0.015. Calculate flow time in the pipe. So time concentration, or TC, for the flow in this sewer EB is simply 10 minutes. Okay, because for TC is from summation of the inlet time and flow time in the pipe, but in our case it's just only the inlet time. So TC is 10 minutes, and duration of rainfall is equal to TC. Okay, so why we choose TD is 10 minutes. Okay, and design, and that is for the 5 years. So we can estimate the intensity of rainfall equal to 4.3 inch per hour. And next we design discharge. Put in equation, Q is equal to 10.3 cubic foot per second. Next, to design the pipe diameter. First find the slope of the pipe EB. Is the difference between the ground elevation at the 2 points divided by the length. Okay, so we can estimate the slope is equal to 0.0064. And next we find the pipe diameter. Using this equation to estimate the diameter, substitute Q, manning end, and slope. So we got 1.71 feet, and this is round up to commercially available pipe is 1.75 or 21 inch. If we want to apply this in for the catalog in Thailand, we can convert from foot to about 0.52 meter, or we can choose that the diameter is about 60 centimeter. Okay, for this sewer. And the next, estimate the flow velocity through pipe EB is by taking the diameter 0.75 and the flow is 10.3. V is equal to Q divided by area, so we got 4.28 feet per second, and inlet flow time is equal to length divided by velocity. Okay, so we got 1.75 minutes. Okay, there is a note that the slight error in this computed flow time is caused by assuming the pipe is flowing full. In case of the partial full, pipe flow can be determined using the Newton insulation from the chapter 5. And after we finish, we can write the number in our number in this table. We finished the silver EB, and we got the pipe size is 175 and flow time is 1.75.